In this video, we're gonna talk about the derivative of the inverse function. So let's say we have a function f of x that is invertible. It means it has an inverse. And we denote the inverse function by f inverse of x. Now, we know that the derivative of the inverse function at x equals b is equal to 1 over the derivative of the function at x equals a. And here we're talking about the point a comma b. So you can rewrite this as f inverse, the derivative at b is 1 over f inverse at a. Let's check an example. Alright, let's say you have the function f of x given as 3x plus 7 over 2x minus 5. And they're telling you verify the rule of finding the derivative of the inverse function at the point 2, negative 13. So we need to verify the rule that we spoke about here. Now, to verify it, first of all, let's find f inverse of x. I'm trying to verify it, and I will show you that this rule is correct. How to get f inverse of x? We know that this is y. So to get inverse functions, you need to replace the y by x and the x's by y. So you start by doing this. I cross multiply. So you get 2xy minus 5x equals 3y plus 7. Now anything that has y, we move it to one side, and anything with x to the other side. So 2xy minus 3y equals 5x plus 7. We take y as a common factor, and we get 2x minus 3 equals 5x plus 7. Now to find the inverse function, we divide now both sides by 2x minus 3. And I know now that f inverse of x is equal to 5x plus 7 over 2x minus 3. Now for sure, if we're solving, we're not going to do all of this. I'm trying to verify the rule. Now, this is the inverse function, right? Let's find its derivative. So what is the derivative of this rational function? Because it's a fraction. So we need to apply the quotient rule, which is f prime g minus g prime f over g squared. F prime is 5 in this case, g is 2x minus 3, minus g prime is 2, derivative of the denominator is 2, and then up we have 5x plus 7 over 2x minus 3 all squared. We simplify this, we get 10x minus 15 minus 10x. Now minus 2 times 7 will be minus 14 over 2x minus 3 all squared. And we get minus 29 over 2x minus 3 all squared. So this is the derivative of the inverse function. Now, they said verify the rule at this point, 2, negative 13. Now in f inverse, we don't replace x. So basically the x that you see in f inverse, it's the same thing as the y of the point. This is the main point here. So if I'm trying to find f inverse here, I should write 13, which is the y, or negative 13 here in this case. So f inverse of negative 13, its derivative will be minus 29 over 2 times negative 13 minus 3 all squared, and we get minus 29 over down it's minus 26 minus 3, which is minus 29 all squared, which is 1 over negative 29, or minus 1 over 29, same thing. Let's try to use the rule we said at the beginning, which is the inverse of x, its derivative is equal 1 over the derivative of the function. Now by the way, when I write f inverse of x, so this is if I have a point basically xy, here it should be the y value and here should be the x value. Okay, let's try to do this. Now we know that f of x was 3x plus 7 over 2x minus 5. So let's write this one. Now to find its derivative, we need to apply the quotient rule. So 3 multiplied by 2x minus 5 minus 2 and then 3x plus 7 over g squared, which is 2x minus 5 all squared. We simplify, we get 6x minus 15 minus 6x minus 14 over 2x minus 5 all squared. Now this and this will cancel, we get minus 29 over 2x minus 5 all squared. So this is the derivative of f. Now, replacing the y value of the point instead of the x in f inverse, let's check if it's equal to 1 over f inverse of 2. Now what is f inverse of 2? Replace 2 here, we get minus 29 over 2 times 2 minus 5 all squared. So we get minus 29 over 1 squared, which is minus 29. So our answer basically will be 1 over negative 29, which is the same thing as minus 1 over 29 as we did before. So instead of doing the inverse function and then find its derivative and then replace, you can get the derivative of the function, replace the x value there. So to get the derivative of the inverse function at the y value of the point is 1 over f inverse at the x value of the function. Alright, another example. So you are given f of x equals 2x cubed plus 4x squared minus 12x minus 4. So let's say this is differentiable at a specific interval and they told you find f inverse of x, or find the derivative of f inverse of x at x equals 4. Now remember, whenever I'm talking about f inverse, the x basically, it's not the exact meaning of x, it's basically the y value of the main function. Now, first step, to do this, I know that I'm gonna do 1 over f prime of the x value related to the 4. So this is basically our y. So I have a point, it has a y value as 4. So it's f prime of the x value of this point. Now, here, if they give you that x equals 4 and it's the same thing as f of 2, it means they gave you the x value of the point, which is 2. And actually in this question, it is given to you that x equals 4, it's equal f of 2. So I know that I'm gonna do this. 1 over f prime of the x value of the point, which is 2. Let's find the derivative on the side. So derivative of 2x cubed will be 6x squared plus 8x minus 12. F prime of 2, we replace 2. So it will be 6 times 4, which is 24, plus 16 minus 12, and the answer will be 28. So our answer here will be 1 over 28. That's it.